I'm the Training and Compliance Manager. We use insulated EWPs for energised maintenance on our transmission network. There's outage restrictions placed on us, and we require to do live work because of those outage restrictions and the restriction of generators to distribute power through the network. So it enables us to operate the system alive, allowing those generators to do their work and sell their power and keep the system going. The bigger units give us more versatility, so 55 metres and above allows us to work on the bigger structures and allows us to do various numbers of tasks that we wouldn't be able to do without an insulated EWP. So we would be tower based or insulated ladder, but with insulated EWPs we've got a greater range of tasks that we can perform alive. Like changing insulators or repair of conductor. Any high resistance joints we can replace bare hand out of an insulated EWP. We can replace damaged sections of conductor, take numerous pieces of debris, kites and the like off the line out mid-span, so we're not restricted by the tower. We can go set up all over the place. They're the major tasks we do. There's often bits and pieces that come up that we can utilise the bare hand techniques with, but they're the major tasks. When we first arrive at site, we'll ask the operator to unpack the boom and wipe the insulated section of the EWP, clean it thoroughly. So once we've cleaned the boom down and we're happy with that, we inspect the moisture desiccant canister that's inside the boom. Because the boom's a sealed unit and it's hollow, we need to ensure that there's no moisture inside that boom. So the moisture desiccant changes colour when there's been moisture in the boom. So we know then if the moisture desiccant's the right colour, that there's been no moisture ingress inside the fiberglass boom. And we also check the atmospheric valves for any hydraulic oil, so that's very important as well. And then we'll check the corona ring to make sure that there's no dents and cracks and splits in that corona ring. And once we're satisfied with all those parts, we'll do a test of the insulation by bonding the basket onto the energised conductor with no personnel inside the basket, and then we'll look at the leakage current. So that's done by the operator on the turret. We'll look at the leakage current and make sure that it's within the set parameters of the voltage that we're working on. Yeah, that's really handy if we can have a machine that can be short legged on one side. Some of our setups are obviously transmission towers are often in remote and quite hilly country, and we try to keep the environmental impacts that we make to a minimum. So the benches we cut in for the setups of the machines are quite small, and if we have the ability to short leg one side of the outriggers, it's very handy for us. We can set them up in a restricted area. Our major concern is ensuring that we have the adequate clearance between conductor phases and between conductor and tower, adequate distance between the gun and the energised phase. So all those things take into account in the scoping of the work to make sure that we can actually physically fit the basket and the operators of the machine onto the structure or onto the conductor safely and maintain those clearances. So we can do scale drawings that insert the bucket into the configuration we're going to be working on, the basket, and if the basket's too big it just doesn't fit on the smaller voltages. So the basket size is important. We don't generally like to have a telescopic basket on bare hand work because it has the ability then to encroach on those safety clearances. The smooth movement and stopping of the basket is important because sometimes we're right up against our minimum approach distances, so you don't want too much overrun because you could encroach on those clearances. So the smooth operation is very important.